Good morning. Thought I would give you an update on the status of my Durisol mineralized wood fiber and cement powder ICF block. 8 months ago I started a test to see what the capillary action through the product would be. I set up a aquarium water pump. This block sits down into the bucket on top of some pedestals that are above the water level, and the pump was continuously bringing moisture or water along this edge and allowing it to absorb the top surface of this outer panel and percolate through down into back into the tub below. I believe this test made the manufacturer nervous. They indicated that it was a totally unrealistic set of circumstances that would never be found in a installed situation, that there would never be this amount of moisture attacking the outside surface of the block. I'm happy to say that it has passed with flying colors. So unrealistic or not, it has some really great anti-capillary properties. If we have a look, we can see that the surface is still wet. I've just raised it out of the test chamber. If we look at the moisture content, we're at basically 100% within about half of my prong depth. But if we now look at the side profile of the block, and I'm just going to relocate here and give you a better view here, we can see that this outer panel, yeah, it's wet, and I'm going to get the same. I'm at about 30%, no, 70% there. It really depended on where the holes were, what the wettest areas were. But if we go in even to a little bit, we can see we're down to 19% if I penetrate. If I go down to past where the insulation is, and I am just at the connecting webs, I'm at 16.6. I'm at 19. If I go back to the inside panel, I'm at 18.6, and I'm at 20. So you can see that even with a fairly aggressive test, 100% wood moisture content on the outside panel, by the time we get to the inside panel, we're basically within the safe zone. Probably the moisture level up higher is more realistic. That's at 16.5, because at the bottom side, that was on top of the blocks that were inside the container, as you can see there, and sometimes those were within a quarter of an inch or a half an inch of the water table, because I would overfill the water. As the water would evaporate out, I would have to keep on putting in new water, and there's times that I did overfill this. There's even times where I overfilled it to the point where the water table was actually touching the bottom of these blocks. And I think just the action of bringing it out, you can see that it's wet right here, the action of bringing out sloughed water around so that it touched the bottom. So if we look at a more realistic number at the top, where it doesn't have that influence of being too close to the body of water, we can see that we're at 16%. I'm going to try to fully embed this we're at 18.2%. So it's responded quite well. The real proof, and I'll just take you around, is to look at our test piece of paper. And you can see that the majority of it is still basically pristine. There is some deterioration down here. That was, as I said, created when I overfilled the test chamber and the water was actually had actually come up to about this level. But this has been here for 8 months, and you can see that there's no moisture effect to the majority. Anything basically above here, there's been no moisture effect to this whatsoever. The other thing that's nice to see, and I'll take us back, is there's absolutely no fungi growth on this whatsoever. It has been leaching out the concrete salts that are in the cement powder. You can see that the water, you may be able to see or may not be able to see. I'll see if I can. You can see it is kind of a yellowish stain. That's just dye or coloring that's come from the cement powder and from the manufactured product. You can see that there's no algae in the water. There's no algae or fungi buildup of any sort on the piping. It's actually responded very well. So this is good news. It generally means that the product doesn't support capillary reactions, so any water that the exterior panel of the block sees will not be transferred through to the interior of the wall. But the test is somewhat unrealistic because, as you can see from above, we've got a hollow core block. So the next part of the test will be to fill this full of concrete to see if the concrete itself helps promote capillary action through the block. And I'm going to do it exactly the way it is situated now, where we've got an uninsulated bay for, say, the R8 configuration of the 10-inch block, or the insulated portion, which would be, I think, a R12 or something like that configuration of the block that I'm planning on using. This is a much larger block that I'm using, but the same principles would apply. So in a few months' time, we'll remeasure this and see what effect the concrete in the core has on the capillary action of the block. Thanks for watching.